All right, this is Mr. Gillum, and today we're going to learn about some inequality rules of triangles. And just so you remind yourself, and it's really important, inequalities are just basically what those are is a greater than or a less than or greater than. Okay, those are inequalities, means something smaller than or bigger than. And so what we're going to do is we're going to guarantee that there's some angle relationships that are guaranteed to be bigger or smaller to other angles, and what we're going to do is we're going to learn about the exterior angles and their remote angles and their relationship. And then we're also going to identify the relationship between angles and their sides in a triangle. That's going to be, I think that part will be pretty self-explanatory, but I think that the exterior angles can be a little bit confusing. So let's get a look here at what we're trying to learn. And the first thing I want to do is I want to remind you of some of these properties that we use for equalities, and I want to explain that they're also viable properties for inequalities. And the comparison property just says this, that A is either less than B, equal to B, or greater than B. Those are the three things that could happen. A is one of those things, all right, or a combination of those things. The transitive property works the same way as like an equal sign. And remember, the transitive property of equality says if A equals B and B equals C, then A must equal C. Well, it's kind of the same thing except for with inequalities. If A is smaller than B and B is already smaller than C, then A must also be smaller than C. If A is bigger than B and B is already bigger than C, then A must also be bigger than C. So it's one of those properties that, it's just a little different because inequality is a little different way of thinking. For instance, if I had A equals 4 and B equals 3 and C equals 2, because I know 4 is bigger than 3 and I know 3 is bigger than 2, I already know that 4 is bigger than 2 as well. Okay, so it's just a transitive property. And then the addition and subtraction properties. And I know you've used these before in algebra, but if we have an inequality, much like an equal sign, if I add to both sides, it will remain a true statement. Or if I subtract from both sides, same way with the less than sign. Okay, so it's just a reminder of your properties of inequalities. They work basically the same way as the properties of equalities, except for we have a less than or a greater than sign. That is going to be important though for what we're about to learn. Okay. The big theorem of the day is the exterior angle inequality theorem. Sounds very long and confusing, but I assure you it's not that bad. Okay. The angles of the triangle that are not adjacent to the exterior angle, that's what a remote angle is. So here we go. If this is my angle here, it's outside the triangle. This is called an exterior angle. It's a continuation of the side of the triangle. All right. And so it's an exterior angle right here. Its remote angles are the two angles of the triangle not adjacent to the exterior angle. So this guy's the exterior angle, and these two would be its remote. There's two remote angles, angle 1 and angle 2. Okay, so it's the two angles that are not adjacent to the exterior angle. Okay, now there could be a lot of different exterior angles to angle 4, any continuation of the sides of the triangle. If an angle is an exterior angle of a triangle, then its measure is bigger than the measure of either of the corresponding remote interior angles. So what that's saying is that angle 4 is guaranteed to be bigger than either angle 2 or angle 1. Angle 4 is guaranteed to be bigger. Now, the reason that is because if you think about it, and this is kind of like the transitive property here, and I didn't really write a slide for this, but I know that through the linear pair that angle 3 plus angle 4 must equal 180. This I know because a straight line is 180 degrees, and these are adjacent angles in a linear pair, so this must be true. I also know, though, that angle 3 plus angle 2 plus angle 1 must equal 180 because there's 180 degrees in the triangle. And so what I can say is that through substitution, if I substitute in what I know 180 is, I can actually prove that angle 4 must be equal to angle 2 plus angle 1. Oh my goodness, mind blown. an exterior angle is actually equal to its two remote angles. So there you go. So in an informal proof, and I didn't really explain my reason or justify anything, I knew that these were supplementary. They equal 180. And I also knew that 3 plus 2 plus 1 is 180. And so if they both equal 180, I can just put all this stuff in for that 180. And I can do a little manipulating here with my addition property of equality, subtraction property of equality. And I know that angle 4 must actually equal angle 1 and angle 2. Or I can generalize that and say any exterior angle must be equal to the sum of its remote angles. In fact, I should probably write that down. Any exterior angle is equal to the sum of its remote angles. All right, so that might come in handy on some of these worksheets we're about to do. As far as setting up your equation, you have to be kind of clever to see it. But the exterior angle is equal to the sum of its remote angles, okay? But specifically this theorem that we were talking about, I got sidetracked there. The exterior angle inequality theorem basically says that the exterior angle is bigger than either part of the remote angles, either remote angle. So in this diagram specifically, angle 4 must be greater than angle 1, or angle 4 must be greater than angle 2. That's guaranteed through the exterior angle inequality theorem. So use the exterior angle inequality theorem to list all the angles that satisfy the condition. Measures less than measure angle 7. So here's measure angle 7. It is an exterior angle to two different triangles. Okay, so we need to be careful we answer both parts. Measure angle 7, its remote angles could be 5 and 4. If I'm looking at this triangle, right there, I know that measure angle 7 must be greater than measure of angle 5. I know that it must be greater than the measure of angle 4 because those are both its remote angles. Or there's a bigger triangle here as well. There's this big triangle right here. It is also an exterior to this big triangle. So I know that it is bigger than measure of angle 1 because this is a remote angle to this exterior angle. And I know it must be bigger than the sum of angle 2 and angle, whatever that is, angle 4. So I know that angle 7 is bigger than angle 2 plus measure of angle 4. So I can conclude that it must be bigger than measure of angle 2, and I already knew it was bigger than the measure of angle 4. So there's 4 angles that I can tell through the exterior angle inequality theorem that I know for sure that angle 7 must be bigger than. If I'm looking for measures greater than angle 6, okay, and I know there's more because you can just tell there's an acute, but specifically with the theorem is what I'm looking at with this theorem. I'm looking, okay, angle 6 is this guy right here. Okay, the angles that are bigger than angle 6. So what I see here is angle 8 is an exterior angle to angle 6. Okay, so I know for sure angle 8 is bigger than the measure of angle 6. Okay, I know that for sure. Now I could also do, well, you know, I don't even want to get into it. In this case, the only exterior that I can see in this diagram to measure of angle 6 is measure of angle 8, this angle. That would be the exterior, and angle 6 would be its remote angle. So in this case, that is the only one that is labeled that we can identify. All right. Now this is, so we kind of breeze through that real quick. This part is almost nearly common sense if you really take a second to think about it. The angles and the sides of a triangle, there is a relationship there. The smallest angle is opposite the smallest side, or the shortest side. The biggest angle is opposite the longest side. And so that's why on our hypotenuse of our triangle, it's always across from the right angle, or the obtuse angle, or the biggest acute angle. And that's just that relationship that you know. So if I had triangle, we'll call this guy 85, and we'll call this guy 25, and this might not be drawn to scale. Call this guy 70. I would know that this length is the biggest because it is the across from the biggest angle. This guy would be the smallest, and this guy would be between the smallest and the largest. Okay, so basically across from or opposite to, and opposite's going to be important when we start doing trig. Opposite to the smallest angle is the smallest side. Opposite to the biggest angle is the biggest side, and that's basically it. That's all. That's really all it is. So if I wanted to put these in order from least to greatest, the angles and the sides, I would say first let's start with what we know. The side themselves from least to greatest would go 1.7 to 2.8 to 3.1. So the smallest angle is across or opposite from the smallest side. So I would say angle A is the smallest angle. This is the second smallest side, so angle C would be the second smallest angle. And 3.1 is the largest side, so I would say angle B is the largest angle. And on this one, we're going to have to do a little more work. I see we have 87 and 46. So I have 133 degrees total. I need to know what my angle K is here just to confirm whether it is the biggest or the smallest or the middle angle. I'm going to say that is 47 degrees. Okay, right there is 47 degrees, so it did make a difference. The smallest angle this time would be angle J, and then angle K, and then angle L, because they just go in order from smallest to biggest. However, the smallest side would be across from 46, so I would say LK is the smallest segment. And then the second smallest would be JL, and the third smallest would be JK. In fact, that wouldn't be the third smallest. We would call that the biggest, or the longest. So that's the relationship between the triangles and their sides, their angles and their sides. And just remember on the exterior angle inequality theorem that the exterior angle must be bigger than either of the remote angles. And the remote angles are the two vertices of the triangle not adjacent to the exterior angle. That's it for today.